Hey there guys, I'm Shomi and this is Advanced Cairo. Welcome back to Groth16 verification part 2. Now it's time to jump into our code and see what our mirror loop looks like. So our mirror loop accepts two parameters P and Q of generic types TG1 and TG2. Then it goes ahead and calls precompute on the parameters P and Q, which provides us with precompute and also QACC, which is the accumulator for Q. Then we call the first and second steps of the Miller loop together on precompute, and then we call Miller bit OP or N based on the bit value for each step of the Miller loop, and this is done like an add chain kind of a way. Finally, we call Miller last to do some cleanup and return our F. So we can see that TG1 and TG2 are part of this Miller precompute trait over here, and this trait actually gives us this precomputed value T pre C, and this T pre C is actually what is passed on to this Miller steps trait as well, and this trait gives us these Miller step functions over here. So that was the Miller loop, and now let's jump on to traits. And our traits are Miller precompute, which, just as we talked about, take in self as a tuple of TG1 and TG2 and return the precompute, which is of type T precomp. It's generic, so it's left over to the implementing developer to come up with based on what they need precomputed to run this Miller steps later on. So now taking a look at Miller steps, we've got Miller first and second for the first and second steps, and then we have individual step functions for bit of 0, 1 or -1. Finally, we have the last step, which is Miller last for cleanup. Each of these steps, sorry, not the last step, but these step bit functions take also an I to keep a track of the step they're on in case it's needed to fetch something from the precompute. And then we also have the accumulator of group G2 and also the F or target group element. So let's get to our objectives, and our objective is to first of all create a suitable type to represent the Groth16 proof. It also needs to include the parameters from the verification key, and as well as the parameters that our prover will provide us. And then we want to find out what the precomputed arguments need to be for the efficient verification. Finally, we need to implement the Miller precompute to do this precomputation. And finally, we implement Miller steps for each step of the Miller loop. Alright, so that's the end of part 2. In the next part, we'll start coding our verifier. So see you then. Cheers.